Nicolai. Nice to see you all. Just for my personal bookkeeping, which version of Java are you using? Who's on Java 7 or earlier? Great. Who's on 8? Everybody's on 8. Who's beyond 8? 9, most likely 11. Couple people. Great. It's good. I see that shift. Like 2 years ago, basically nobody was on 9 or later. And now, actually at conferences, more people are on 9 or later than are on 7 or earlier, which is great. Okay, so today we're going to talk about var, which is new in Java 10, which means just a handful of you can actually use it. And but the rest can learn how to do that in the future. Originally, my idea was for this talk to just touch on the rules a little bit of how to use var, and then we're just going to play around with it because you can do some crazy things with it. But when I gave this talk the first time, I got the feedback that no, people actually really want to learn how to use var properly before just doing crazy stuff. So if you came for the traits and for the ad hoc fields and methods, and just for that, then now is a good time to reconsider you being here, because we're most likely not going to get there. I spent much more time on rules now, so you get a good feeling on how to use this feature. The slides are online, so you can go through them, but the slides are not really very informative. But then there's also the code online, which you can have a look at if you want. Just hide that down there so I don't drop it. There you go. Okay, so let's start with the rules. Let's start with the code right away. Now, I have a lot of glare here, so I really hope that this, well, you know what? I just turn a little bit so I can read there. Okay, so we're kind of used to write code like this. This looks very, very normal. It's so normal that if you would not know the topic of the talk, you probably wouldn't even know what could possibly be wrong with it. And nothing's really wrong. There are just a couple things that could be improved, namely the types here, the type information. This codefx variable is of type URL. Well, duh. I just create a new URL on the right-hand side. What else could it be? I open a connection, which, surprise, surprise, is a kind of a connection. And then I create a reader, which, once again, is a reader. None of that is really surprising, but we still have to put it there, most likely not by typing. The IDE helps a lot. But still, like, this information is there. It's redundant, and it blocks your view on more important information. But we don't, this is not strictly seen a necessity. The compiler knows what this is because the compiler knows what this is. So, well, if this is URL, then what else could the thing on the left-hand side be? And here's where var comes in. Var allows us to say, okay, you know what? Let the compiler figure this out. Let the compiler determine these types, and there you go. And we're done, we can leave now. That's really that covers like 80% of what you have to know about var. You can just put var here instead of a type, and other than that, things work as you would expect, right? So this is not dynamic typing, this is not JavaScript. This is just a compiler feature where the compiler puts the type here. And we can actually ask IntelliJ, for example, what this would be. And if you go on var and ask it with Control Q so if you have a reader here and you press Control Q, it will show you the Java doc for reader. And if you go on the variable and press Control Q or whatever it's on your machine, it will show you the type. And with var, the same thing is still true, right? So basically, all this information is still there. It's just that we don't have to put it there anymore. Okay, so that's really just the very basics. Now let's play around with this a little bit. Let's see where we can use it and how we can use it. So this is obviously one use case. You can use it for local variables. Let's immediately go where you cannot use it. So let's say we have a method. Actually, it takes an argument. Let's say we have a method like this one. Where we cannot use var is here, for example. Nope, doesn't work. Doesn't work here either. Cannot use it for fields. You can really only use it for local variables. And that's on purpose, because with var, a little bit of information is lost, right? Usually you would like to know what types things are. And the idea here is within a method, that's easier to understand, even without the types being there. But across methods, and even worse, across classes, that would be much more complicated. So that's why var is very limited to just what happens inside a method. Besides local variables, another good use case would be for a for loop. So you could, if you wanted, and I never type for loops. Let's see. like this, right? That's how you type a loop. There you go. I made it on the first try. Now you can do this if you want to. It's not a great improvement. I'm just telling you where you could use it. Another interesting thing is that I think this could be closed, right? I think here we could use try, I think. Let's see. I hope that we can. We should be able to use, oh, sorry. That was not, that's for later. Rules. Yes, rules. What? Oh, I pasted something. That's the reason. Let's see. I think, right. So now we have a try statement. And now here we can use reader, right? Here we can also use var inside a try statement. And that's really it. That's really all the places where we can use it. For local variables, inside try with resources block, and for loops. And that's the use case there. There are a couple of cases where you can't actually use it where you might expect it to. So for example, let's say we have a couple of integers here. And you can create an interface, an array like this, right? Yep. I make a lot of typos. You have to get used to that. Okay, so we can do this, but we can also create that with a shorthand like this. If you use that shorthand, then you cannot use var on the left-hand side. I will tell you in a second why. Another place where this doesn't work is with lambda expressions. So let's say we have a function here, and it does nothing useful. It just appends a string, a space. Sorry, there you go. Also, you cannot use var here. And the reason is the same for both cases. The reason is that this thing on the right-hand side doesn't actually have a type, a fixed type. It can be several different things. So for example, it cannot only be an integer array, it could also be a long array. It could also be an object array. So the thing on the right-hand side doesn't really know what type it has. And if you put var here, then the left-hand side doesn't know what type it has, and then both sides are like, meh. And then the compiler can't fill in the type. And the same is true here. A lambda expression does not have a specific type, right? This could be a function from string to string, but it could also be a function from object to string. It could also be a unary operator of string. You can create your own functional interfaces with that kind of structure, and it would all match. So the compiler really doesn't know what this could be, which is the reason why this doesn't work either. Both of these are so-called, did I mention the word? Poly expressions. They're called poly expressions because they have kind of one of several poly of several types. That's why they're called poly expressions. And then you cannot use var with that. Okay, did I cover everything? I guess we did this, method signatures, poly expressions, we did that. Okay, yeah, two more things. The compiler really doesn't try to be too clever. So if you declare an int here, then you can of course like assign it later, and then you don't have to put this on the same line, but with var you have to put this on the same line. And the reason is that var doesn't try to do something clever. It doesn't try to determine the type by looking at all the assignments and checking all the assignments and trying to find a super type. What you could imagine would be, let's say we say I is 0 here and then I is a string here. You could imagine, wait, but there's a super type here. Let's serializable is one of those. Serialize. There you go. So both an integer and a string are serializable, right? So there is a type for which these assignments make sense. And you could think that maybe var could infer that type. But it doesn't. It doesn't try to be clever, not because this would be complicated to implement, but because it would be more complicated for us to understand. Looking at this code, it's really easy to understand what I is without looking at whatever happens down there, because it only looks at the right-hand side of the assignment and nothing else. So that's why it infers int here, and why down there you get a compiler error. Right, so var is simple on purpose, so it's easier for us to understand. Okay, do you get a good feeling of where you can use var? That's good. Then let's go to one more slide before we go back to code, because the next question is, hey, wait a moment. I need types to read code, which I do too, so I get that. And the idea could be, wait, you just included this feature to save a couple of keystrokes, so typing gets easier. Really, that's why we have this feature. And the answer is no, that's not why we have that feature. This is actually about readability. The goal here is to make code more readable even though there is less type information, because there are other advantages. So I would argue that var starts at a disadvantage, because the code contains less information, but in very many circumstances it can make up for that. With less redundancy, it's easier to create intermediate variables. There's a higher focus on variable names, and you can align variable names. And I'll show you what I mean by that. By going back to a little bit of code, have a look here, where is it, readability, there we go. So let's start with less redundancy. We already saw this example. And just in general, I think, it's not too bad to just remove redundancy because it keeps the eye on the ball, on the important part. And the important part, arguably, is a variable name, and even if it's the type, it's still there on the right-hand side. So that's one advantage that you have. And remember, in this case, these are very benign type names. Think about your code base with enterprise-grade type names plus generics, right? These are usually way longer than this. And this code font, they probably would leave the window on the right side here. Okay, so less redundancy is one thing. Another thing is that you can include more variables. Now, we don't really have to understand the details of this, and in fact, this stream pipeline doesn't really do anything useful. I just wrote the code so it's there. So we have some kind of canvas, which some kind of drawings, and this returns a stream, and IntelliJ already gives you a lot of information here, right? This is not a comment, IntelliJ put that there. So it's a stream of drawings, and we filter this, and then we map this, and we filter again, and we did a couple of maps. So it's not even a really complicated stream pipeline, but a couple of things are happening here. And apparently the developer didn't use IntelliJ or thought ahead and think, wait a moment, somebody might want to do a code review for this, and then we don't actually have IntelliJ for that, or want to look at this on GitHub. So you know what, I'll leave a comment on what exactly I have when. So here, now we have lines, and now we have squares. And we know that when we write clean code, we don't want to do this with comments, right? Ideally, you want to do this with variable names. So okay, let's introduce variables to make this more readable. Let's say we have now we have lines here. So let's ask IntelliJ to create a variable here. There we go. Create a variable here, and let's call it lines. Okay, let's create another variable here for our squares. And now who thinks this got more readable? Because you can't even read the right-hand side anymore, right? Because I did this time actually add some weapons-grade generics and type names. And now, this is really hard to read, the squares and the lines. This thing, the important part they want to introduce, this word, all but disappears in this sea of letters. But look at this. So, to be clear, I would not have done this in real code because this does not improve readability. I'm not sure how often I will do this, but I know I will do it occasionally because this does improve readability. Now you can see lines, squares, and then we're done eventually. So this is an important aspect, that introducing variables usually has a cost when you have large type names and with long type names. And with var, you can skip that cost and you can focus on the variable name here, which is the next thing, emphasizing variable names. So I wrote some code here which has horrible, horrible variable names. L and LW and CR and then N, of course, because it's a name, I guess. And U, and then we need another U, so we go with UU, right? So this is the horrible code. But one could think that it's almost acceptable because it still has all this type information here, right? Why do I have to write credentials twice? It already says credentials here. Come on, I don't have to put CR there again. So write credentials here again. I would argue you kind of have to because you use it somewhere down there and then it would be nice to know where it is. Now let's assume we're using var everywhere now, right? So just, is there a quick fix for that even? No, I don't think so yet. Let's say we use var everywhere here. Now this becomes really obvious that it's really bad to read because now without that type information, you actually can't read the code anymore at all. So with this additional focus or emphasis on variable names, it becomes more meaningful to actually use proper variable names here in the first place, which we should have done anyway, but now there's more emphasis on that. If you use var, you have a much higher threshold for the quality of your variable names. But that's good because you should write good variable names in general. So I think this is worse. But I would argue if you now put proper variable names here, then the version with var and good names is better than the version with types and bad names. Not everybody might agree, but just the fact that you now, this is clearly unreadable, and this will not get past any code review, I hope. And, oh yeah, we have one more though. I think there's one more. Yeah, right, there's one more. The aligned variable names. This might seem like a really small thing, but I'll give you a second to look at this piece of code, and try to understand what's going on there. There's a small joke hidden in there. Okay, so the variable names are trying to tell a story, which I think good variable names should do in general. Let's see whether you can see the story. Right? So, if you do it, if you give your variables good names, then they demarcate steps in. We could call it an algorithm. Well, it's not really an algorithm, right? But whatever you're doing there, the variable names tell a story. And this way, you can actually make that very readable. And the reason for that is twofold. First of all, now they're all aligned. And the other reason is because var is, it's not really a keyword, but it's close to being a keyword. Because var is like a keyword, it's highlighted like one. And as a developer, you're used to switching between do I care about keywords or not. And when you don't care about keywords, you just ignore them, and you just see only these kinds of names. And so I think this also is more readable than the other variant. So this is about readability, and there are ways to use var to make code more readable. That doesn't mean that using var everywhere will make code more readable. It's a trade-off. Okay, so because the Oracle team is aware that this is not a thing that you want to use everywhere all the time, they created some official style guidelines. They were created by Stuart Marks from Oracle. I think he did it on his own, but then he worked together with Simon Maple to create a cheat sheet, which I will link later. The guidelines have 4 principles and then a couple of concrete guidelines. We're going to look at the principles on slide and then at the guidelines in code. So the first guideline is, the first principle is reading code is more important than writing it. But even though var seems like a thing that saves you some keystrokes, it's not meant for that. You should not use it to make writing easier. You should only use it when you can make reading easier. And you should be able to understand code with or without var, actually, from looking at as little code as possible. I mean, you can't always do that, right? Code tends to be complex, and that's okay. But do your best to make it understandable from just looking at a little bit of context. And that's true here as well. If you have to look all over the place in a long method to understand what type of var variable is, then that's not good. Then really, probably you should put a type there. Don't rely on your IDE. Even if you do, when you can do code reviews actually in your IDE. But still, code might end up in situations where you don't have an IDE. So even though 90% of the code at least is read through an IDE, remember that this is not always the case, and make sure that it's not that you don't rely on this, because as I said, right, you can always ask, where we go, here we are. You can always ask IntelliJ for the type here, and that's nice. But don't rely on that. Don't assume that the code is only readable because you have an IDE. And then the last one is important too. We're used to putting explicit types everywhere, but that doesn't mean that it's a zero-cost version, right? It also has upsides and downsides, and var, we have to compare var to that, and not just to the assumption that explicit types are the norm and they have no trade-offs. They have trade-offs as well, like long names, for example. Okay, these are the guidelines, and they're just here for completeness sake. Let's have a look at them in code. Guidelines, where we are. There we go. Okay, so let's start. The first guideline is choose variable names that provide useful info. So here we have a user repository that loads a user, so it stands to reason that this is a user, but still it would be nice to use something else than this kind of variable name. You can, of course, call it user. That's acceptable. What I try to do is, in this instance, use a variable name that tells the reader of the code, what is this user here for? Why am I dealing with that user here? Because the class names that I use, they apply to a large code base, right? So for example, think about the list that you use from the JDK. The concept of list applies everywhere in the entire ecosystem. Calling a variable list in a very short context of a small context of a method seems like you're losing information. Probably you're not using any kind of list, you're using this list for a specific purpose. The user is something that exists in your entire application, but why do I have a user here? Maybe I want to lock that user in, whatever. Like there's something that's specific to the user in this context, and I would add that to the variable name. And I think var gives us an incentive to do that because it gives puts more emphasis on this, on the variable names. Okay, so choose variable names that provide useful information was the first one. The second one is minimize the scope of local variables. So here I varred a variable up here, and then, you know, it's a long branch, and then more code. Oh boy, much more code. And then down here I use that thing. If I look at this code now, then I have a hard time, like, what was ID again? What type was it? Like, even with explicit type, you tend to forget. So in general, you don't want to do that, right? You want to keep methods short, and var is just an additional reason to keep methods short, and hopefully it's possible to put the entire else block and if block each in a method, right? And then this would be much more readable. Jay, I wonder when you can just put a bunch of comments into a method. Let's see what IntelliJ thinks about that. That was the if branch, right? Oh, you can, look at that. Oh, what did I do wrong? Cannot perform refactoring. Selected block should represent an expression. Well, anyway, why did it work before? Never mind. That's weird. That seems like a bug, actually, because the same is true up there. But as I said, never mind. Okay, that was the second guideline. Third guideline, consider var, consider var when the initializer provides sufficient information to the reader. The initializer is the thing on the right-hand side. And here I didn't use a user repository to load a user. Here I'm using code that is not really that informative. I'm using repository to load. What? Well, nobody really knows. So even though I gave it a name, still the right-hand side doesn't give an additional information for what this might be. I think this is not okay. I think this is better. If you have, this should be the name, should have been the name. So now user pops up often enough so that I really have confidence that this is probably a user that I'm getting. The best place to start with var, if you're skeptical, if you want to use var but you're really not sure where, the best place to start with is for constructor calls. Because here there's just no doubt what this thing is. There are no interfaces involved, there's no polymorph here, it's just like it's a user. That's very, very clear. So this should be your starting point. If you cannot convince yourself to use var here, then you shouldn't use var at all, or your team shouldn't use var if they can convince themselves. So this is like the first step to use var in these situations. Okay, that was guideline 3. 4, oh boy, I should really have looked at this in presentation mode. Use var to break up chained or nested expressions with variables. We already did that, right? But this is, in the guideline even mentions that. Consider using var here to create variables where you would not have done it in the past to keep code readable. Don't worry too much about programming to the interface with local variables. So what we would have done with explicit types would have been, oh no, it's a user. Would have been this, right? This is an interface, and then we can create the concrete implementation here. We're just used to that. We do that out of habit. But it has a reason, and the reason is if you use an array list here, and for some reason you later determine you want to have a linked list, which I guess, did that ever happen to anybody? Because like it's a thing that people tell you never happened to me. It happened a little bit with map. Like I used a hash map and realized, oh no, wait, maybe I need a concurrent map after all. But still, rarely. Anyway, but it's with collection types that maybe happens less often, but it happens more often with your code and your interfaces maybe. So the thing is, we're used to putting interface on the left-hand side and the concrete implementation on the right-hand side. And that's in general a good approach. Now, what happens when you use var here? When you use var here, you don't get that anymore. When you ask IntelliJ what users is, it's an array list, right? So it's not a list anymore. And what's the downside here? The downside is that the code you write here accidentally starts using something that is specific to ArrayList. And then later when you replace it with a linked list, or a more sensible example that makes sense in your code base, then you're stuck. Then you can't exchange it because now you relied on specifics and not on the general interface. And all of that is true, but in a small method, I think the risk is really reduced. So if you have methods returning ArrayList instead of list, if you have fields that are ArrayList instead of list, there's a more reasonable chance that this might actually happen, that you might actually depend on something that you don't want to depend on. I would argue for local variables, that's not very likely. And if it is, it's hopefully easy to fix. So that doesn't mean that you should throw that programming to the interface out the window, but I think it's not that important here in that context. One caveat. Let's say the method grew a little bit, and now I want to extract a method here because I want to make it shorter. It's like fill user list, whatever. If I do this, then IntelliJ will extract the concrete type here, because that's the type that user had, right? Users were of type ArrayList, so now ArrayList is here. And that's what I think is where the bug stops. Here you should really be like, wait, this is not okay anymore. It should really be a list here, because otherwise you run the risk of proliferating the specific type through your code base. So now it's ArrayList here, and then maybe it's also you return something as an ArrayList, and then at some point you make this public, and suddenly you have an API that requires specific types instead of the interface, even though it may not even need that. So yes, don't worry too much about programming to the interface. I want to add a but if you refactor, make sure that you use the interface. In fact, you could use a more general thing here. I don't know, does collection have an add method? Not sure? Yep. So you could actually, in general, like even if this would have been a list here, which is the reflex, when I extract methods, I try to think about what is the most general interface that I can put here. When you iterate over it, maybe it's just iterable. So that applies in general, but that's more important with var, because you run a higher risk of extracting specific types into your signatures. Okay, IntelliJ ate the space here that I put here. There you go. Take care when using var with diamond or generic methods. So, if I put var here, what do you think happens? Error. Why? Because I asked, right. The reason is, if I put var here, then before I said I want to have an optional of string here. And the method empty kind of relies on that. If we look at empty, we see that it has this free-floating generic parameter here. And when the compiler looks at this, it knows, okay, so this is a free-floating t, but because of the left-hand side, well, t must be string. So that's why it gives me an optional string. And then I can call or else, and this thing then also has to be, is a string, and then also or else returns a string, which is what I want to have here. If I put var here, the right-hand side doesn't get that piece of information anymore. So the compiler infers object. And then this thing returns object. Right? So if I put object here, then it compiles. Now, first of all, you could fix that if you want, because you can specify what t is here, which is kind of uncommon. But you should know that you can do that. And sometimes you actually need to do that because the compiler can infer the right type, even without var. But this is something that you have to look out for. The same is true, by the way, if you just do the really normal thing like list of strings. There's new array list. Oh, great. That worked like a charm. There you go. Okay, now if you var this, it will turn into an array list of object. Because nobody knows what type you want to have there, so the compiler will infer object. Right, so as soon as generics are involved, you have to look at the right-hand side and take a look whether the information that was once there on the left-hand side is now actually reflected on the right-hand side. Usually, if it isn't, you will find out somewhere. At some point, you will usually get an exception, right? Because if you rely on this strings list to be a list of string, then surely somewhere that is reflected. For example, if I have a for each loop here, then as soon as I var this won't compile anymore because, hey, this is actually an object. So you will see this somewhere, right? It's more unlikely that the error will slip by unnoticed and then cause problems at runtime. I don't even know how to construct such a scenario. But you will get compile errors otherwise, most likely. Okay, nope, one too many. There you go. So take care when using var with diamond or generic methods. And another place where you should take care is with literals, because this thing on the right-hand side here is not actually a long. This is an integer, but you know an integer can also be a long, so that's not a problem, you would think. But if you put var here, then this is not a long anymore. You would have to use this. And it never infers byte and short, for example, so these are now all ints instead of bytes and shorts. But I wouldn't do that in the first place, honestly. I don't see the advantage here. I mean, var has two advantages. It's colored like a keyword, and it's shorter than the long type names. But here you save literally like one character or two, and you already have the same color. So I would just never use var with int or long. Well, maybe not never, there may be a reason at some point, but by default I wouldn't do that. I see no reason that by default to use var here. So I would recommend not to. Okay. Those were the 7 guidelines. And if you want to learn more on var, on the basics, there's a YouTube video where basically I tell the same story that I just told now, so don't look at it. There's also a blog post that I wrote in writing if you prefer learning that way. The official style guidelines are linked here. And then the cheat sheet that I mentioned earlier, it's just a one page, and you can just print it next to your, put it next to your screen. And then the things that I just mentioned are all on there, so you can kind of get in the habit of using var the proper way. Okay, now you know everything that you need to know to use var properly and in the right context, and I think you're settled for it. Do you have questions about that? You can also ask me later or after during the rest of the conference, although I'm not here tomorrow, but later today. Okay, so now let's start doing crazy things with var. Let's start with intersection types. So, what is an intersection type even? I will quickly introduce that. Sometimes you're in the situation that you need a type that has to be of 2 different interfaces. I'll give you an example in a second. But you cannot actually create a new interface. That's what you normally do, right? So you have something has to be of type A and of type B. Well, you just create a new interface that extends A and B, and there you go, you implement that. But sometimes it doesn't work. So let's say you need something to be closable and an iterator. But you cannot create a closable iterator interface. And the reason why you couldn't do that is because there is a class over there which is closable and is an iterator, but you can't change it because it's not your code. And sometimes you want to handle that. And it's called an intersection type because if you think about, there's confusion, is it an intersection type or a union type? It's an intersection type. If you think about types as being like a big sack of all the things that are of that type, and all the things that are closable are here, all the things that are iterator are here, and the things that we're interested in are the ones in their overlap. The intersection between the 2 sets, that's what we're interested in, the intersection type closable iterator. A union type would be both of them, but never mind. Intersection type closable iterator, that's what we want to do. That's what I just explained here, and what I basically want to have is a variable of type closable and iterator, somehow. Because we want to call close and has next and next. That's the goal here. And now let's see how that works. Cool pineapple dude, by the way. Let's see, let's go to the intersection types. So let's start over. We have this simple piece of code here. It creates a scanner, which reads system in. And then we have this method first match here, and we look at that in a second. We give it this scanner, and we also give it a predicate that some string is not blank. Okay, and whatever comes out of that, if it's present, we print it. So what does first match do? It gets an iterator of elements, and it gets a predicate to apply. And then it streams the elements. This is a helper method that's somewhere down there. It streams the elements from the iterator, filters by the condition, and checks whether any element is in there. But pretty straightforward. Okay, so this works in practice, and now everything is fine. And then someday somebody comes and says, crap, I passed something here that was closable, and nobody closed it, and now my code broke. And you're like, well, you could have closed it somewhere else. Like, no, we need to do it here. Okay, we need to do it here. So what you would like to do is this. You would like to close elements. And if you're not on Java 9 plus yet, you might wonder, wait, don't I have to reassign here? You don't have to reassign anymore if this variable is never changed. But it doesn't work because elements is not closable. So what now? What you would have is something like this. That would be neat, but that doesn't work. Okay. Now, as I said, you could create an interface that is a closable iterator. It's very simple. It's a single line. Interface, closable iterator extends closable and iterator. But the problem is that scanner doesn't implement that interface. And you can't change that because it's not your class. Okay, so what now? This is not illegal everywhere. It's illegal here, but there's a place where this ampersand is legal. Do you know where? Right. So now we can start playing around. So we introduce a new generic type. What did I call it? I don't remember. Let's call it T. I'm pretty sure there's a better name out there, but let's call it T. And we do this. Actually, use it here. And there you go. Why doesn't it work? Wait, what? I think this is supposed to work. An exception. Oh yeah, sure. Ha ha ha. At. So there we go. That's the best way of exception handling, right? Great. So what we do here is we create a new generic type, and we tell the compiler, look, t must be both of these for this to pass. And but if we have one of such t's here, then we can actually use both. We can use it as a closable, and we can use it as an iterator. And that's pretty neat. And we didn't even use var yet. So that's kind of nice. Okay, now a new thing pops up. So we used var. We used this crazy thing, this intersection type here. We used that as an argument. We can also use it as a return value. Somebody comes in and says, look, we're not always using a scanner. Sometimes we're using something else. Sometimes we have something which might be empty. There's a class down there which is called empty, which also implements the two interfaces. So now we want to have a method which, well, let me type it again. T extends, oh, or it doesn't really matter, right? Closable and iterator of of string actually, because scanner is an iterator of string. There we go, and it returns that t, and we call it whatever, create maybe. Okay, and the idea here is if it's empty, well, then we just return empty. That's a new, as I said, that's a class down there that is really boring, does nothing. But apparently it doesn't have the right types. Let's see. Else, we return a new scanner from system in. System in. Oh yeah, right. So these are not declared as this thing. So we have to trick the compiler. Like don't tell anybody that we're doing this. But this works. So I think we would get an unsafe cast warning here. But this is not literally unsafe. It's just that the compiler can't prove that this works. It works. This is not a problem. This will never lead to runtime problems. So that's pretty great. Let's use create up here, and this is where the trouble starts. Because it's a problem. How do we want to create a variable here, right? That's what we did before. We want to create, let's say, true. And we can use it as a scanner. Can we now? Wait a moment. Oh yeah, right. Because of the generics, this actually compiles now. But this will fail at runtime because, well, we're returning an empty here, and empty is not a scanner. So we have to somehow repeat that information here. We somehow have to get the closable here. But we can't. This doesn't work. And this is where var comes in, because the interesting bit is, and you can already see this with the generics, the compiler knows more, well, the compiler has a richer type system than the JVM. The compiler can do stuff with types that the JVM doesn't understand. And one of those things is it can infer, or rather, well, that's also true, but what's also true that we can express even fewer types in the language. Right? So you have the language, which is the least powerful, then the compiler can know a whole bunch of stuff, and then the JVM is somewhere in between. Because the cool thing is you can put var here, and then this is actually, if you look at the bytecode, you would see that this is actually of the type closable and iterator of string. So we can use var to assign a type that we can otherwise not express in the Java language. And we can use this in situations like these. So what would I recommend using that? Well, so it has a couple of downsides. One of the downsides is it uses a lot of type inference and generics. And both of those topics are not exactly beginner friendly, right? So you have people working on your code base who are somewhat new to Java, then they will not most likely not look at this and say, yeah, I know what's going on here. Well, unless they come from a type system that actually also has intersection types. But this is kind of roundabout. So this is not this adds complexity. But there are situations where it's the only tool you have at your hand. And in that case, I would say, then use it. So this is more like, as I said, this is more like we're playing around with this. But by accident, something came of it that you can actually use, I would say, in extreme circumstances. So we've seen this. The idea here is if you want to use intersection types, you use generics to express this intersection. For example, here for create closable iterator, or here to pass it as a parameter. And then if you have to, you can just, if you don't have to use var if you don't have a variable for it, right? If you just inline this, then you never have to use var anywhere, but you most likely wanna. And then you can use var for that to have variables of that name. As I said, it combines some non-trivial language features, and refactoring becomes a little bit harder because if you pull a method out, then you're stuck with a situation that now you want to return maybe a variable that has this type information, and IntelliJ will not infer that. It will refer a concrete type, and then things fall apart. Then you have to go back in and add all of this generic stuff again. So that's not ideal. So refactoring becomes harder. But in general, intersection types are a known thing. It's not something I made up for this talk, right? So this is the thing, and so there's a concept for that people might know, and it can be really helpful if you don't have another solution at your hand. Okay, we got a couple more minutes, and we have definitely not enough time to look at how to get to traits, but I can show you on the slides. Oh yeah, or written blog post. I can show you on the slides what I mean by that, what I mean by traits. Okay. A trait, so while I'm 100% sure that the definition of intersection types or the description of intersection types I just gave you is correct, traits are a little bit more murky. I'm not 100% sure, so don't bet your livelihood on this explanation being correct. But sometimes you want to attach functionality to an instance that you already have. You have an instance of something, and you just want to add a couple of methods that you can then later call. But you don't want to create a new type for that, right? So you don't want to do this at compile time. You basically want to, at runtime, put stuff together. So let's say we have an interface called megacorp, and what we don't have is somehow attach functionality that checks whether this megacorp is successful. And the idea behind a trait is that you can do that. A trait extends the megacorp interface and adds functionality, and then a language that supports traits allows a simple way to just take that trait and just tack it onto the side of the megacorp instance you have, and there you go, you can use all of that behavior. We would look at code now, but we don't. So here's how you do it, and it's not easy, and I'm not saying you should, it's just how it works. The first thing that you do, you have this megacorp interface here, and the first thing you do, you create another interface that extends it. It has this single abstract method, megacorp, which is a delegate. I will show you in a second why you need that. And then you need to implement all of megacorp's API with default methods that forward each call to this delegate, right? So somebody calls on this interface, calls foo, and the implementation would be a default implementation for foo that just calls a delegate and calls foo on that one. Okay, that's the first step we need. That's kind of like a technical requirement to make this work at all. Then we create traits as interfaces. We have this is evil interface for megacorp, and you know all megacorps are evil, so that's just true. But if you want to add is successful, then you can do that. You can use all the megacorp API here, and you would use default methods to add your additional features. Now here comes the trick. You use a lambda expression here. And I already mentioned that the lambda expression is a poly expression. That means it doesn't have a concrete type. You can cast it to something, and this is actual valid Java syntax. You can cast it to the intersection of these interfaces, the lambda expression. You could not do that with anything else. You can just take a variable and cast it to this. You'll get a compile error. But you can use a lambda expression to cast it to this, and then you can assign this to a vard variable. And so this original is just a megacorp, but you cast it to this, and what you get now is something that has a megacorp API, but it also has the isEvil API. So that's pretty neat. That's the trick here. Now, would you want to use that? I'd say definitely not. The first thing is the part of complexity that I mentioned earlier. Lambdas, poly expression are complex, type inference, generics, default methods, all this plays a role here. And then refactoring becomes harder as well. This thing is a pain to write, but the most important part is it breaks in collections. And the reason for that is the megacorp classes, the classes that extend the megacorp interface and that have, the proper classes, they will have an equals method that most likely, they will have an equals and hashcode method that makes some kind of sense. If you write the megacorp delegate, you can delegate all kinds of methods to these megacorp classes. What you cannot delegate are methods that exist on object. That's just a limitation of default methods. You cannot create a default method for a method that exists on object. There's a reason for that as well, but I'm not going to go into that. So what that means is that the delegate cannot forward to the implementation of equals or to the implementation of hash code. And that means when you put one of these delegates into a map or into a list even, then things fall apart very, very quickly, because a megacorp class might equal one of these crazy delegated traded things, right? Because the implementation on that class is used for the equals. But if you turn that around, if you use the delegate and call equals on that one, it refers to objects equals, which means, well, we just look whether it's the same instance. So you have A equals B, but then not B equals A, and that's really not a good thing. So this is why it breaks in collections and why you can really never use it in real code. It's fun to play around with and to get to know the type system a little bit, but you cannot use that in real code. Also blog post. And that's that, we're going to skip that. It's neither particularly interesting, it's fun to play around with, but it's not something that you will use a lot, and also it doesn't work for the same reason. No, not for the same reason. For different reasons it doesn't work, so I don't also recommend not to use that one. And with that amount of time, thank you very much. As I said, if you have questions, come to me now or after the conference. During the conference, you can ask me anything you want, and now I'll just let you go to the next talk or to lunch, I think, right? So, thank you for your attention. Bye.